Let us look at static variables in recursion. We have seen how to trace recursion. We have also seen how a recursive function utilizes a stack. Then, what if there are any static variables? How to treat them inside recursive function? So here I have an example function, recursive function. Though there are no static variables right now, without static, this function, I will trace it and show you. Then if a static is introduced, then I'll show you what should be the difference. First, let us see what the function is doing. I will read it out. I'll explain what these things are. See, there is a function fun which takes parameter n. If n value is greater than 0, then it will call itself with the degrees value of n and also add n. So when this plus n will be done, calling time or returning time? It is done at returning time. Then if the value of n is 0, then it returns 0. And from main function, this function is called by passing a, that is 5. Now to show how they will work inside the memory, I have already taken a diagram for the memory where I am showing code section, both the functions are there. Then how the stack is used, I'll explain you. First of all, I will trace this function for value 5 and show you the tracing tree. First, the function is called for the value 5. So this is fun of 5. And 5 is greater than 0, yes, so it will call this one. So it will call itself for fun of 4 plus this n. So let it be blank here. That will be filled with the value of n. And what is the value of n here? 5. I'll use it afterwards. Then it will call itself for 3 plus 4 should be added. I'll leave it as a blank. Then fun of 2. 3 should be added. I will leave it as a blank. Then fun of 1, 2 should be added. Then fun of 0, 1 should be added, and fun of 0 is 0. This is 0. Now when it goes back, this is 0 plus 1, this is 1, so this will be 1. And the result of this one is 1 plus this is 2, so this will be 3. Then the result of this is 3 and this is 3. So this will be 6. So the result of this one is 6 plus 4, this will be 10. The result of this one is 10 and 5, so this will be 15. So the result of this is 15. So this is the tracing of a function when it is called upon value 5. Now let us see how the activation records are created. Then the activation records for fun will be created. Value of n will be 5. Then value of n will be 4, value of n will be 3. So this is how stack is created. Every time for each call, a new variable will be created inside the memory and it will have its value. That is 5, then 4, then 3, then 2, then 1 and 0. So all these values are newly created every time whenever the function is called. This we are aware of local variables of a function. Now I am going to make changes in this function, then we will see how to handle static variables. So I am making modification. Static variable, integer x, whose value is 0 initially. And before calling, I'll be incrementing it. And while returning, I'll be adding x. So this is not adding n, adding x, and x is incremented. And it is static. So first of all, where these static variables are created, they are created inside code section. Or there is a subsection of a code section called as a section for global variables and static variables. But I am showing directly inside code section. And the value of that one is 0. Will this static variable be created every time whenever the function is called? No, it will not be created every time when the function is called. It is created only one time, that is at the loading time of a program. So this x will not have multiple copies just like n, it will have a single copy. So all these calls of this function, they will use the same copy of x. So I cannot have a separate copy each time like n. For n, every time a new copy is created, but for x, there is a single copy. Now, what will be the result of this function? For that, I will trace it again. So for that, I will remove these things and I will trace it again. Let us look at the tracing and see how static variable should be handled. For a static variable, it is x, so I should have a single copy of static variable separately. Don't show it in the tracing tree. Now let us start. First time the function is called by passing value 5. So n value is 5. First time fun of 5. Then if n is greater than 0, yes, it is greater than 0, x plus plus, this x becomes 1. Then call itself fun of 4 plus this x will be added at returning time, so use it at returning time, don't use it now. Continue for this call. Again 4 is greater than 0, x plus plus, so this x becomes 2. Call function of 3 plus x should be added at returning time. Then call greater than 0, x plus plus, call itself. So 3 call for 2 x plus plus, then plus this x should be added. Then for this call, again this is 4 and call for 1 plus x should be added. Now for this call, this becomes 5 and call for 0 plus x should be added. Call for 0 returns 0, so the result of this function is 0. Now it will start returning back from here. So this is 0 plus x has to be added. So what is x now? 5. So this is 5. Result of this is 5. Then x should be added. What is x now? 5. So this is 10. So the result of this function is 10. Then plus x should be added here. So what is x now? 5. So this is 15. See, in the previous example, we were adding n. So n was having its own value in each call. So those values were used. But now there is only one single copy of x. So each call will use that same copy, and right now it is having value 5. So that same 5 is utilized by all. So this result is 15 plus 5. So this is 20. Then 20 plus 5 is 25. So the result of this function is 25. So that's it. This is how you should handle static variables. If there are any static variables inside recursive function, don't show them in each step of tracing tree. Write them just like a global or outside variable and maintain a single copy of it. So sometime we need to use static variables also in recursion. So I have shown you how they work. Now if it is not static, if I take out this variable and if I declare it outside like a global variable, then also the result will be same. So static variable will have a single copy, and even global variable, it will have a single copy used by all the function calls. And those global variables are also created inside code section. And every call will use the same copy, and the result of the program or the function will be same. So in the previous example, the result was 15, but now for 5, the result is 25. So here in printf, result will be 25. So in the coming examples, we will use this recursive function with static variables.